Okay, welcome back, week 6. Here we go with the week that represents the 2/3 point of fourth quarter. So we are 2/3 of the way done with fourth quarter at the end of week 6. All right, that means we only have 3 weeks left after this. And it also means since it's week 6, we have a test this week. So every third week we're going to have a test. So it's week 6, so we're having a test this week. So what we're going to do today is, instead of dealing with just rational expressions, we are going to actually turn irrational expressions into equations and be able to solve them. And another way to think about it is we're just going to be solving equations that contain fractions. And one of the things that we have to be really good at when we're solving equations containing rational expressions is multiplying fractions by an integer. And so what we're going to do here is we are going to take each one of these fractions and we are going to multiply it by an integer. Now, if you want to try this on your own, you could stop the video right now and then restart it and see how I did it to see if you did it the same way or if you got the same answer. All right, so when we're multiplying a integer by a fraction, what we do is we multiply the numerator times the integer. So we have 18 times 1 is 18. Whoops, that pen is way too big. Got to make it smaller. Did that work? Yeah, it did. So 18 times 1 is 18, and then we put it over 6, and then we always want to simplify. And in this case, 18 divided by 6 is 3, so we can simplify this to 3. Okay, similarly, we have 12 times 2/3, and we have now a number other than 1 in the numerator, so we just do 12 times 2, which is 24. Put it over 3. And notice how I'm not multiplying the 12 times the denominator. I only multiply the 12 times the numerator, because another way to think about 12 is it is actually a fraction that is 12 over 1. And so we would multiply 12 times 2 and then 1 times 3. But we don't have to do it if we can just remember integers get multiplied by the numerator. And then 24 divided by 3 is 8. Okay, and then changing gears a little bit, throwing a variable in there. We can throw a variable in there. It's going to be the same process. We multiply 20 times x and put it over 5. And in this case, we can simplify the 20. So we're going to just simplify as if that x isn't even there. 20 divided by 5 is 4, so we end up with 4, but then we can't forget the x, 4x. Okay, we'll simplify like the x isn't there by just dividing the numbers, but then keep the x when we write our answer. All right, and the last one, I should have chosen something different. Although this is all right. Actually, this is good because this is something that's going to happen quite a bit. So we do the same thing, 4 times 3x, so that's 12x. I got to rewrite that. That's bugging me. It's all over 4. And then 12 divided by 4 is 3. So we have 3x. And so you can see that in this case, it may have been easier just to right away go say, hey, those 4s are going to cancel each other out. So we end up with 3x. Okay, so that's one thing to think about, is we're going to see things canceling like that. And that's something that we want because it's going to help us solve these equations. All right, so if we are going to be solving equations containing rational expressions, the first thing we have to do is we have to find the LCD of all the fractions or rational expressions that are in the equation. Okay, and then what we're going to do is multiply the entire equation by that LCD. So we're going to multiply by the LCD. And then what we're going to do is we are going to simplify first, kind of like what we were doing up above, exactly like what we were doing up above. We're going to simplify and then solve. Okay, so when we simplify, what we're going to do is eliminate the fractions, and that's what we want. We want to be able to eliminate those fractions so the equation is easier to solve. Okay, so if we look at this first example, And this is where you have to kind of be good at finding the LCD, and this one should be fairly quick. We should be able to say, hey, I know my LCD is 6. Okay, so when I know my LCD is 6, what I'm going to do is I'm going to take this entire equation and distribute a 6 to every single term inside the equation. So this is going to be just like the warm-up, except now we're going to have to do it 3 times because we have 3 fractions. Okay, so what we end up with is we end up with 6x over 2 plus 48 over 3 equals 6 over 6. Okay, so I just did what I did up above. I multiplied that 6 by every single numerator that I have here. And now what I can do is I can simplify. I can simplify by dividing. So 6x over 2 becomes 3x. Hold on a second. Did I just totally mess up? No, I didn't mess up. I don't like the way this is written because of all the equal signs. So I'm just gonna do this. Instead of an equal sign, I'm gonna just draw an arrow like that. Okay, so we have 3x, and then 48 divided by 3 is 16, and 6 divided by 6 is 1. So you can see we took a fairly complex looking equation with 3 fractions in it and turned it into a fairly simple equation now that we can solve without too much difficulty. And so this one we can solve by subtracting 16 from both sides. So we have 3x is equal to negative 15, and then we can divide by 3. So x is equal to negative 5. Okay, so pretty straightforward once we eliminate the fractions. Okay, so no matter what we have, we're going to follow the exact same process. So we're going to always find the LCD. We're going to multiply by that LCD, and then we're going to simplify and solve. All right, so in this case, again, another one that's fairly obvious. The LCD is going to be 18 because 2 goes into 18, 9 goes into 18, and obviously 18 goes into 18, right? So we're going to, I don't know why my iPad keeps doing that. We're going to distribute an 18 to each one of the terms inside. And this one is going to get a little trickier because we've got binomials, and if we're not careful with these binomials, we are going to mess up. And so what I'm going to do is use red so it's obvious and put those binomials in parentheses. I'm only going to use red the first time. So now what we have to do is we have to distribute that 18. So now we have 18 times t minus 4 over 2. Okay, and then we have minus 18 times t minus 3 over 9. I know you're tempted to distribute the 18, but don't do it because we're going to be able to simplify that 18 before we have to distribute it. Okay, and then we have 18 times 5. And this one I'm just going to write as 18 times 5. I'm not going to write it as, I'm not going to actually multiply 18 and 5 because this is kind of like that last one where we can just cancel that 18 and it's going to be just a 5 left when we do that. All right, so what do we got here? I'm going to see where I have them. Okay, I can go off here to the right still. All right, so if I go off to the right, the first fraction, 18 times t minus 4 divided by 2, since it's 18 times, parentheses t minus 4, I can just divide the 18 by 2, so that 18 becomes a 9. All right, so here we go. I'm going to draw a little arrow, so I have 9 times t minus 4, and notice how nothing happened to what's inside the parentheses, and that's okay because it's multiplication. And now we have 18 divided by 9 is 2, so this is 2 times t minus 3. And then this last one, remember I just said, hey, these 18s are just going to cancel, so we end up with just 5. Okay, so we have an equation now with 2 sets of distribution in it. So I'm going to distribute that 9, and then I'm going to distribute the negative 2. So I'm distributing the 9, and I'm going to distribute the negative 2 Why did it not show up? That's weird. Okay. So I'm going to distribute the 9. Oh, I see. My hand is down here, writing on the bottom. That's not good. Here, let's erase that. Okay, so I distribute the 9, so I end up with 9t minus 36 minus 2t plus 6. Remember, when you distribute a negative, it changes the sign. So the t is now a negative t. It's a negative 2t. And the negative 3 becomes positive 6. And then the 5 just stays a 5. Okay, so now we can combine like terms. So I'm going to combine this and this and that and that. Notice how I got those signs in there? That's really important. So 9 minus 2 is 7. So we have 7t. 7t, not 70. And then negative 36 plus 6. So we're going to take that 6 away from the negative 36. So we have negative 30 is equal to 5. Okay, so then it's fairly straightforward to solve from here. We're going to add 30 to both sides. So we have 7t equals 35. And then we'll divide by 7. Whoops, that's not. I tried to make a 7 out of my fraction bar. So t is equal to 5. Uh-oh. Don't think that everything's going to be a 5 or a negative 5. It's not going to work that way. Ooh, I need to erase more down here. There we go. All right, so, whoa, I used a lot of, here we go. Let's do your guys' magic trick here. Whoops, I don't want to do that. I missed something. There we go. All right, so now we got one that has something other than a number as the denominator, and in this case there's only one fraction, so the LCD is just going to be whatever the denominator of that fraction is. So we're going to distribute an x. I keep doing that, that's bugging me. Okay, so I have to distribute 4 times here, and I'm distributing on both sides of the equal sign just like I did in the other two. It's bugging me that it keeps jumping. Why is it doing that? Okay, so there we go. I'm going to put my sleeve over my hand so it doesn't do it. All right, so we end up with 3x minus 6x over x. See what's going to happen there? Equals x squared plus 8x. All right, so we should be able to see what's going to happen here now. This x is just going to cancel itself, and that's what we want. We want that x to go away because we want to get rid of that fraction. Okay, so we end up with 3x minus 6 equals x squared plus 8x. All right, so this one is going to bring back some things that we did in the past, that solving a quadratic equation. So what we have to do is get everything on one side of the equation and have it equal to 0. All right, so I am going to subtract 3x. So I end up with negative 6 equals x squared plus 5x. And then I'm going to add 6. And, you know, sometimes people like to put the add 6 underneath one of those and then they actually add it to it. And so I'm just going to put it over here on the side. Okay, so we end up with 0 equals x squared plus 5x plus 6. Okay, so there we go. That is a quadratic equation. Now the 0 is on the left-hand side. That's okay. You could flip this whole thing around if you don't like that. As a matter of fact, let's just do it because most people seem to not like that. So we have x squared plus 5x plus 6 equals 0. And then we just have to factor it into binomials to find our two answers. And so we have x plus 2 and x plus 3. So our answers, remember, are the opposites of the numbers that are in the binomials. So we have x equals negative 2 or negative 3. Okay, now the only thing we have to be careful with when we find an answer like this is we have to just go back to our original problem and say, if I plug in either one of those numbers, does it make the denominator of that fraction 0? And the answer is no, because it's just an x down there. So that means both of our answers are good answers. Now, if you ever run into a situation where one of your answers make the denominator of a fraction 0, then we have to eliminate that answer. And hopefully it's going to happen in one of these last two. We're going to find out. All right, here we go. Now with these, if I try to show the distributing and everything, it's going to get kind of messy. So I might try to do this one a little bit differently. So what I'm going to do is I'm going to notice that this first fraction has a trinomial that can be factored. And I can factor it into a couple of binomials. So I'm going to do that, 4x over, and I know it's going to be x plus 6, x minus 5. And then I'm going to rewrite the rest of the equation, and I'm going to put these binomials in parentheses like we should to make it easier. Okay, and then what I'm going to do is I'm going to notice that my LCD is just the denominator of that first fraction. Okay, and I'm just going to think through what I'm going to do here. I'm going to multiply that first fraction by the LCD, so it's simply going to cancel the denominator. So my first fraction is just going to become 4x. The second fraction I have to multiply by that whole thing, and the x minus 5 will cancel. So another way to think about it is, what do I need to do to turn that denominator into the LCD? Well, I have to multiply by x plus 6. So that means the numerator needs to be multiplied by x plus 6. And then similarly with the last one, since it already has an x plus 6 in the denominator, I need to multiply by an x minus 5. So I'm going to have, sorry, that should be an equal sign. 1 times x minus 5. Now, we don't technically need the 1, so I'm not going to write it. It's just going to add an extra step for me. Okay, so essentially what I did was I multiplied by that LCD. I would come out here and say, all right, I'm going to multiply it by x plus 6, x minus 5. But when I did, I'm just kind of simplifying things. I'm saying, hey, this canceled and that canceled, right? This canceled, but then I needed to have an x plus 6 up there still. And then this canceled, and I needed an x minus 5 up there still. Okay, so hopefully that makes sense. And with these, it's a lot of writing if you write the whole thing out. But if you need to, go ahead and do it. You know, it's okay to write everything out if you need to. All right, so what am I going to do here? Well, I need to do some distributing. So I'm going to take this problem and I'm going to move it up top here. Okay, so we have 4x, and then, wow, not wanting to cooperate. And then I'm going to distribute the 2, so I have 2x plus 12. And then that's all equal to x minus 5. And notice how I'm getting rid of the parentheses now, because now the parentheses kind of get in the way when we're trying to solve an equation. Okay, so I want to get all the x's on the left-hand side, the numbers on the right-hand side. First thing I can do is combine like terms, though, so I'm going to combine these two. And so I have 6x, dang, plus 12 equals x minus 5. Okay, I'm going to subtract x from both sides. So we end up with 5x plus 12 equals negative 5. And then I'm going to subtract 12. So I end up with 5x equals negative 17. Well, this is kind of a fun number. Whenever I get fun numbers, I like to double check. Make sure I didn't mess something up. It looks good to me. All right, so then I just have to divide by 5. and I get a fraction as my answer. So that should be right. We could know for sure if we went back and plugged it into the equation. You should try it. It's fun. All right, let's keep rolling. One more. Now, double check, right? Do we have to worry about one of the denominators becoming 0? And the answer is no, because we have this weird fraction. If we would have ended up with a +5 or a -6, then we would have had to eliminate one of those two answers, but we don't have to in this case. All right, one more. And here we go. So in this case, it's hopefully fairly obvious what the LCD is. The LCD is going to be x minus 2. Okay, and just another way to think about these is, hey, when I have my LCD as x minus 2, I know it's going to eliminate these, and then I have to multiply this by x minus 2. If I can write it, come on. And this by x minus 2. Okay, so just another way to think about it. Instead of having to write everything out, just say, hey, when I eliminate that denominator, I'm going to eliminate that denominator, but then anything that doesn't have a denominator needs to be multiplied by the LCD. Okay, so that's another way to think about how to do these. So the first one we end up with, I'm going to write down here so there's a little more space, x times x minus 2 plus 14 equals 7x plus, we don't need to write that 1. When it's plus 1, we don't need to write it, so I'm just going to say plus x minus 2. Okay, so I'm going to distribute in the first one here, so we have x squared minus 2x plus 14 equals 7x, and then with this I'm just going to get rid of the parentheses because it's just addition and I can do that. If it were subtraction, if it were subtraction, I don't want to just get rid of it, I got to distribute a negative, right? But in this case it's addition, so I can just write like that. All right, and now anytime we see a squared term, x term numbers, we're going to think quadratic, so we're going to want to put everything on one side of the equal sign and hopefully get it equal to 0. Okay, so, but before we do that, we got to combine like terms. Let's combine those like terms. So we have x squared minus 2x plus 14 equals 8x minus 2. Okay, so now I'm going to jump back up over here. And so my next step is going to be subtracting 8x. I'll write it down here, but we'll do it up over there. Subtracting 8x from both sides. Okay, so when we subtract 8x from both sides, we end up with x squared minus 10x plus 14 equals negative 2. Okay, and then we're going to add 2 to both sides. So we have x squared minus 10x plus 16 equals 0. And then we know we're going to make binomials. And in this case, it's going to be x minus 8 and x minus 2. So we have x equals positive 8 or positive 2. And in this case, if we look at that 8, we can plug it into the original equation with no problems whatsoever, because 8 minus 2 is 6, and we can have a denominator of 6. But the 2, if we plug the 2 in there, 2 minus 2 is 0, and we can't have a 2, or we can't have a 0 as a denominator. So that means this answer is eliminated, and my answer is only x equals 8. All right. You got an assignment to do on your own here. You can email me if you have any questions.